Good evening, my dear students. We'll start with the next session of Module 3, that is knocking off gasoline or petrol. What do you mean by petrol? Petrol means it is a mixture of hydrocarbons. These hydrocarbons, it can be branched chain hydrocarbons, straight chain hydrocarbons, cyclic hydrocarbons, or aromatic hydrocarbons. Okay. So, in an internal combustion engine, what happens is that the petrol air mixture, it will be compressed first. Okay, so that is what written here. Mixture of fuel and air, it is compressed by piston and it is ignited by an electric spark. Here, smooth and complete combustion occurs if the hydrocarbons are branched, cyclic or aromatic, as they can resist pressure. All these three types of hydrocarbons, they can resist pressure during the compression, and therefore smooth combustion or complete combustion will be taking place. As a result, the flame produced, it will spread smoothly and hence knocking will not be produced. Okay, so when it is a branched chain hydrocarbon, cyclic or aromatic hydrocarbon, they can resist changes in pressure during compression, and hence the flame produced, it will spread smoothly and thereby knocking will not be produced. Instead, if straight chain hydrocarbons are present, what happens is that during compression, straight chain hydrocarbons, they cannot resist pressure. As a result, incomplete combustion takes place. So, it results in the formation of unstable peroxides. Straight chain hydrocarbons, if present, they will combine with oxygen and result in the formation of unstable peroxides. These unstable peroxides, they will decompose rapidly, releasing gaseous compounds throughout a chain reaction. Okay, and hence the petrol air mixture, it will burst suddenly into flames at a higher speed with a rattling sound. That means knocking will be produced. Okay, so this is what happens when straight chain hydrocarbons are present in the petrol mixture. So straight chain hydrocarbons, what happens is that they cannot resist the changes in pressure and hence they will form unstable peroxides. Unstable peroxides, they will decompose rapidly, releasing gaseous compounds through a series of chain reactions, and the petrol air mixture, suddenly it will burst into flames at a higher speed with a rattling sound, that is called knocking. So what do you mean by this rattling sound? Rattling sound means it is the sound. An example is the sound that is formed when the dishes are unloaded from a dishwasher. The sound that is produced, that is called a rattling sound. A similar sound will be produced from the IC engine. Okay, and this sound, it is referred to as knocking. So how can you define knocking? Knocking can be defined as the rattling sound produced by the shock waves in a petrol engine due to explosive combustion of fuel-air mixture at higher compression ratio. This is referred to as knocking. Okay. Now, we'll see the mechanism of knocking. See, under ideal conditions, under normal conditions, slow oxidation takes place and results in the formation of carbon dioxide and water. Say for example, this is, here we have taken ethane as an example. So ethane, it combines with oxygen and form carbon dioxide and water. So this is the ideal condition whereby slow oxidation of fuel is taking place, resulting in a smooth combustion which leads to the formation of carbon dioxide and water. Now, when knocking occurs, what happens? The rate of combustion, it is very high. It's very high and it takes place in the following steps. That is, the hydrocarbon molecule, it will combine with oxygen forming peroxides. Okay, so here we have taken ethane as an example. So ethane, it combines with oxygen. This oxygen molecule, the two oxygen atoms, it come between the two methyl groups, that results in the formation of CH3OOCH3, that is dimethyl peroxide, because this oxygen, two oxygen atoms attached, it is called a peroxide group. Okay, so ethane combines with oxygen and forms the corresponding peroxide, that is dimethyl peroxide. This dimethyl peroxide formed, it is unstable. So unstable peroxide, what happens? It decomposes readily. As it is unstable, it will decompose readily to give a number of gaseous compounds. First acetaldehyde will be formed. Okay, this dimethyl peroxide, it forms acetaldehyde. Acetaldehyde, again it combines with oxygen and forms formaldehyde, that is HCHO, and carbon dioxide and water. Again in the next step, this formaldehyde again combined with oxygen and form carbon dioxide and water. So these unstable peroxides, they will give rise to a number of gaseous compounds through a series of chain reactions. Okay. Now due to the formation of gaseous compounds, the fuel air mixture, it burst into flames, producing shock waves which hit against the walls of the cylinder with the rattling sound, and that is referred to as knocking. Okay, so that is the mechanism of knocking. Now we'll see the ill effects of knocking. That is, first is it increases fuel consumption and reduces the efficiency of engine. Whenever knocking is there, fuel consumption will be more as well as the efficiency of engine will be reduced. Now second is it causes mechanical damage to engine parts like spark plugs, piston, etc. Okay. And third is it reduces the life of the engine. Whenever there is a mechanical damage to the engine parts, definitely the life of the engine will be reduced. So these are the adverse effects of knocking. And now how to prevent knocking. Knocking, it can be prevented or it can be minimized by making use of anti-knocking agents. And examples for anti-knocking agents are tetraethyl lead, tetramethyl lead, etc. So these are anti-knocking agents. These anti-knocking agents, when it is added in little amounts to petrol, they can reduce knocking because they will increase the octane number. They will increase the octane number of the fuel. What do you mean by octane number of the fuel? Octane number means it is the percentage by volume of isooctane in a mixture of isooctane and normal heptane, which will exhibit the same characteristics of the fuel. Okay, so here upon addition of anti-knocking agents, we can increase the octane number of the fuel. A fuel with a higher octane number, it is said to be a good quality fuel. Okay, fuel with a higher octane number, it is said to be a good quality fuel. So by making use of anti-knocking agents, knocking can be minimized because they will increase the octane number of the fuel. Okay, so that's all for this session. And if you have any doubt or any other questions, then we'll see in the interactive section. We'll discuss in the interactive section.